Okay, topic 1.3, so it's going to be on review on descriptive statistics. So previously we have seen what is descriptive statistics. So it's actually like a confirmed number. So how do you get those numbers and what kind of numbers are they? So this is what we're going to have a look at in this particular subtopic. And from this stage, we're going to start doing calculation. So you better have your calculator with you for this particular subtopic. Okay, so there are going to be like a lot of numbers that we're going to come across. There are multiple ways of summarizing our data. Summarizing means that like even, what does that mean? It means that like you have a bunch of data all together, and instead of like presenting all the data that you have, you're going to summarize this in terms of one number. So that is what we're planning to do. And we can either use measures of central tendency, where we're going to measure the center of the data itself. We're going to have a look at measures of variation. We're going to have a look at how varieties your data are. And then we're going to have a look at measures of position. So if we were to divide your data into two categories, is it going to be the lower categories or is it going to be in the upper categories and so on? So that is going to be in terms of measures of position. Where does it stand among all those data? So if the measurement describes about population, so this is what we have seen in the previous subtopic. So anything related to population, any number, so given from a population, so that is going to be called as being parameter. Any numbers that come from sample, that is known as being statistic. So a rule of thumb, so this is going to be the rule for the whole course starting from chapter 1 until chapter 6. So what happens is that every single time you do your calculation, so it has to be in terms of 4 decimal places. If I mark your paper and the calculation is not in terms of 4 decimal places, I am entitled to actually deduct your marks for it. Okay, so please make sure that everything is in terms of 4 decimal places. If you have a number that looks like this, 1.25, so it doesn't matter then, just leave it as 1.25 because this is just 1.2500. So simply you can write it as 1.25. But what if your calculator gives a value that looks something like this? For example, 1.333333, the whole thing on the calculator. So until what extent should you take the number? Remember, the rule of thumb is 4 decimal places. So it's going to be 1.3333. So this is going to be the number that you're going to use in your calculation. Okay, so if the unit is given, the value should be rounded to that unit's decimal places, for example. So what does it mean by that? For example, your data is about people. So when it comes to about people, so I do calculation. Okay, so I figure out that it's going to be 2.35 people. How is it possible to have 2.35 people? So therefore, what you're supposed to do is you're going to round it up. So this is going to be like about 3 people. So 2.35, that is going to be 3 people. Or so if it in terms of what else? Something that is going to be in terms of like height, it doesn't matter. It could be 4 decimal places. Weight could also be 4 decimal places. But if it's something like, for example, cars, number of cars, number of people, so please make sure that whatever number that you have, it is a meaningful number. So 2.35 people is not meaningful. How are you supposed to have 2.35 people? So therefore, it's going to be 3 people instead. Okay, so this is how you use your scientific calculator. And if I were not mistaken, this 5x50ms, so this is going to be the dark gray calculator. If you have this, then this is going to be the instruction that you have to follow. So first of all, press the mode SD, insert the data. And if you wanted the data summary, so this is what you're going to have to go through. I don't promise when I'm going to do this because I only have my white calculator with me. And actually the white is the best one because it actually have more functions compared to the older model ones. But I do not encourage you to buy a new one just for that sake. Okay, if you already have an existing one, just proceed to using whatever that you have. But if you had the white calculator, that is going to be it's going to be an advantage for you. And the Casio FX570ES, if I'm not mistaken, this is going to be the silver one. This will be the silver calculator. All right. And if I have time, I will try to borrow the calculators from my friends and I will make a video like sort of like step to step. How do you find this value from each of the calculator model? I would promise you it's going to be this week, but I'll try to make this before next week. Because like when we start with chapter 2, so you should have the idea already how it's done. Or you can actually Google or YouTube for it. So it's definitely going to be on the internet. And different calculators could actually give you different notation, so you have to be very careful. So have a look very carefully, so which what do you call that, which symbol is used by your calculator. So which one is for sample, which one is for population, and so on. First, we're going to have a look at measures of central tendency. As I mentioned just now, what is measures of central tendency? We're going to come out with one number that actually measures the center of the data. Okay, so measures at central tendency, also called measures of average. So how do you calculate this average? So you can either use the mean value. I think that among all these four terms, I think that mean should be something that you're familiar with. And there's median, mode, and also mid-range. So if we have a set of data, we can sort of like figure out what is going to be the middle value of your data just from these two statistics terms. So the measure of central tendency I used to describe an entire set observation with single value. And the single value is actually the central or the middle value of the data set. So let's start with the first one, which is mid-range. So mid-range, according to the definition, is a rough estimate of the middle. So what is going to be the formula for mid-range? So it's going to be the lowest value plus the highest value and divide by 2. For example, if suppose this is going to be my data set. So from my observation, I noticed that the lowest value will be 1, the highest value will be 8. So all I have to do is pick those two numbers, divide that by 2, and my mid-range value is going to equal 4/5. So what is the characteristic of mid-range? So mid-range is going to be a rough estimate of the average. And however, like one of the drawback about mid-range is that it can be affected by one extremely high or low value. Okay, this extremely high or low value, so which is known as outlier. So it could either be an error value, or it could also be a value that is actually real. It is actually part of the data set, but it is actually a value that is out of norm. For example, let's say if I were to collect data which is in terms of height, I get that the first person, the height is 152, the second person is 169, the other person is going to be 180, so the other person is 149, and suddenly I have a very big value, so which is going to be 216. So what happened is that, so this data over here, it could be like mistakenly recorded. So it's actually not supposed to be 216, but it's actually written by the person who collected the data. Or it could also be a real value, that there is actually exists a person that is this tall. Okay, how do we identify whether this value is going to be an error or a real value? So there is actually a formula that we can use. Okay, so from the data itself, we can sort of like make an estimation. So whether this data set actually belongs with the rest of the data, or it is actually an error value that we should discard from our data set. So we're gonna have a look at the formula later. So that's why when we have outliers in our data set, so a value, it could be very low or it could be very high compared to the rest of the data, so you might not want to use mid-range. So mid-range is not a good way to represent the center of the data. So therefore be careful. So if you come across values like this, so consider using anything else aside from mid-range. It could be mean, it could be median, and so on. Okay, now let's have a look at the second term, which is going to be mean. Mean is also a way to measure the center. So according to definition, mean is the sum of the values divided by the total number of values. So here, this is basically just the same thing, but one is going to be for population and the other one is going to be for sample. Remember? So we have seen this previously, that when you have population and sample, the notation that you use will be different. For the case of population mean, you use the symbol of mu, and for the case of sample mean, you use the notation x bar. But in terms of the formula, it will be the same. All you have to do is you sum up all the number, you add all of them together and divide by the number of how many numbers there are. And for the case of population mean, you're going to divide that by population size, that is denoted by capital N. And when you have sample mean, you divide that by small n, which represents the sample size. Okay, for example, over here, so if this is my set of data, so I have a numbers data set of 1, 3, 5, 7, 7, and 8. So altogether I have 6 numbers. So I add them all up together, 1 plus 3 plus 5 plus 7 plus 7 plus 8, and divide that by 6. So here it is not specified whether this data come from population or sample. If the data come from a population, so I will use the notation mu equal 5.1667. If this data come from sample mean, is actually sample mean, it comes from sample, and I will use the notation x bar equal 5.1667. So depending, so where does the data come from? Is it from population or is it from sample? So do you have to use the correct notation in your calculation later? The answer is yes. So if it's supposed to be mu but you write it as being x bar, then you wouldn't get marks for that case. You have to be very careful, have a look very carefully whether it's going to be from population or sample. Okay, and you can find if you want to sort of like try to use your calculator to find, so the mean value is going to be there. You don't have to like add everything up. All you have to do is key in the data and you can get the mean value from your calculator, and it's going to be x bar. And for the case of mean, the value of x bar and mu is going to be exactly the same because they use the same formula. And then we also have the median. So the median is also a way to measure the central tendency of a data set. So median is the middle number of n ordered data. So first thing is that I want you to notice this term, it says ordered data. So how are you going to order the data? It's going to be ascending, starting from the smallest value to largest value. After you have ordered them, then only you can figure out the median. So if you don't order them, you couldn't figure out what is going to be the median. The number cannot be jumbled up. Okay, so if I have like a value of 1, 8, 6 first, I have to rearrange them. The smallest is going to be 1, followed by 6, followed by 8. So that is how it is ordered from smallest to largest. Okay, the formula will be different depending on whether n is even or odd. Remember, n is our data, how many are there in our data. So if n is an odd number, odd means it is going to be a number that is 1, 3, 5, 7, 9. So those are odd numbers. And n is even numbers are numbers that are multiple of 2. So it could be 2, could be 4, could be 6, could be 8, could be 100. So those are all called as being even numbers. So depending on your data set, you're going to decide whether you're going to use this formula or this formula. Okay, so here, this is an example. I have 1, 2, 3, 4, 5. So my n value is equal 5. So this is going to be the case when n is odd. So when I want you to use a formula, so I'm going to have to substitute the value of n right there. So I'm going to have x 5 plus 1 over 2. So this is going to be x3. What is x3 actually? So this 3 over here is actually telling you the position of the number. So it's not the number itself, it's actually telling you about the position. X is actually the data set. The data set is called as being X. So in the data set, so we want the data at position number 3. So where's the data of position number 3? So when I count, this is number 1, number 2, this is going to be my X3. So data that is in position number 3. So that is why, so my median value is going to equal 5. And it's going to be the same idea when you have an even number as well. So here for the second data set, I have 1, 2, 3, 4, 5, 6. My n value is equal 6. It's an even number. It's a multiple of 2. So when I apply the formula, so I'll end up with x 6 over 2 plus x 6 over 2 plus 1. And that is going to be divided by 2. So here is going to be x3 plus, so this is actually a number right next to, if it's x3, then the next number will be x4 and so on. So it's going to be x4 over 2. So what is going to be the number in the third position? So this is going to be my x3. And this is going to be my number in the fourth position. So it's going to be 5 plus 7 divided by 2. So that is how you get the number 6. Okay. But actually the easiest way, so this is going to be a non-formal way of doing that. All you have to do is arrange your data. For example, if I have a set of data of 1, 3, 6, 7, 8, I have 5 numbers. So if I wanted to figure out what is going to be the middle of this, I know that I'm going to have 2 numbers on the left, 2 numbers on the right. So the middle is going to be 6. So 6 is going to be my median. Okay, so that is going to be a way as well. Or if I have even numbers, I have 1, 3, 6, 8, 9, 10. But remember, you have to order it first, smallest to largest. So on this side, I'm going to have 2. The other side, I have 2. So this 2 is going to be my middle value. So if I want it to median, all I have to do is add them both together and divide by 2. So that is going to be one way of figuring out medians without using the formula. So that is also possible.